Hi everybody. Today I'm going to talk about using the flip-flop only one, the flip-flop as the frequency divider. Let's say make half, of the input frequency. So what are we going to start? Let's take a look at the flip-flop right here. Let's say 7474. This is my D flip-flop. And then what I'm going to do is we're going to the way we do it. Basically, most of people understand how to make the divider circuit, frequency divider circuit. But this one I want to show you how it works. Let's say to get a better understanding about how you know uh, the DeFi flop works. So what we're going to do is that we connect Q bar to the input of the same flip-flop, right? And then this clock turn out to be your input. So what I'm going to do, I'm going to give the input to the clock. So I use the digital clock, right? So the HGCROCK. I'll place this right here, close. And then as the preset, let's say I'm gonna connect the preset to the logic 1, right? So I can also use the whatever, like in this case I'm going to use the V what DC, and let make it to the 5 volt. So I change this attribute to 5 volt. And then I also need a ground AG and D, otherwise this won't work. Always give you an error. And I connect this one to preset. Now the problem, okay, hold on a second. And I also connect this one to the clock. Let's say here I'll set up uh, the power width on time and off time, or let's say, let's make it 1 second. Off time, 1 second. Click OK. And then next step is the problem just right here. If you were um, not clear the output Q, you will have problem because you have no logic, coming out to Q or to feedback to the input D. So what I'm going to do is I'm going to just use this one, um, give the pulse signals to clear. But as you know, just like we just need a short start, to reset Q in output. So what I'm going to do, and then after that, we don't need to clear because otherwise you have problem with your output, right? So uh what I'm going to do, I just like reset Q, just for a moment, and then after that, I need to give the logic 1 to clear, right? So what we're gonna do is like we go to attribute, and then let's say off time, just to be very short. Let's put like 0.5 microsecond, and then after that it's going to be like on time. So I put this is a large number. Let's make it 10 second. Click OK, And then you also go to need to set up. You go to transient, so that's why I put like final time to be 10 seconds. And then simulate. Let's take a look at what um, clock pulse first, right? So this is what we have, right? Because we have like set up on time, off time to be 1 second, and then on time to be also 1 second, and we have the period of 2 seconds, or the frequency is like 1/2, so that makes 0.5 hertz. Next one, we go to let's say to see clear, right? Just right here, just start. As we said, this is 0.5 microseconds to be logic 0, and then after that uh, you have like logic 1 to the pin clear, right? Because you don't want to reset uh, output Q. Let's put cursor just to get better picture. And then the last one, of course, we want to see your Q output. Okay, and this is your Q. All right. So if you take a look how it's work, um, let's see here. Let me get a pen, and then as you notice, you will see this is the period of your input signal. You take a look at the clock, right? Pulse, just right here. But for the Q output, let's say you start from here is better. See, it's going to be a double of the period of your clock signal, or the frequency is going to be like half of the frequency of the input signal. In this case, the input signal is the gain from the clock, right? Pin. Okay, let's see how it's worked. As you know that when the it's gonna change the state of your output or Q output when you have the positive edge or positive edge trigger, or you change switch from 0 to be 1, and it's gonna happen again just right here, and then going to happen again just right here. And for the output Q, it won't change any state until you have the rising edge or positive or trigger, positive edge trigger coming in. So when you have the rising edge right here, your Q is was reset to be 0, and then when the signal is coming in, um, it's gonna change the state, right? Just right here, rising edge, follow the clock signal, and then it's gonna stay 1 logic high until you have the next um, rising edge clock pulse is coming in. So this one is gonna change the state from 1 to be 0, and then it's gonna come back, uh, change the state from 0 to be 1 again when the rising edge or the positive edge trigger of the clock signal is coming in. So this is how it works. Now look back at the circuit just right here. When this is how it works. The first step, you reset your output, right? So your Q is turned out to be 0, and then Q bar, of course, is become 1, and then it's feed the signal back to D, and D is just now become 1. When the rising edge or the positive edge trigger of the clock signal, and which is also input, you mean like the input in the term of, or you want to divide the frequency by half, and you want to get the output, pulsed, at Q. Okay, when the positive edge trigger is coming in, you have this is 1 going to transfer your logic 1 to Q. Now Q is not 0 anymore, it's turned out to be 1, and your Q bar, of course, to be invert, so it becomes 0. Feed the signal back to the input again, and waiting for another clock pulse. When the positive, edge trigger coming in again, it's send what? Uh, Now it's turned out to be 0, right? So it's keep Q to be 0, and then of course, Q bar turn out to be 1, and so on. It's just like cycle. Okay, hopefully you get some idea a little bit. Um, this is I just want to explain, how it's worked to make it more understanding by using just really piece-based. But some people can explain better, by just using words. But this one is just like, okay, I show you by plots and show you by the circuit. Okay. Thank you very much. I'll see you in the next YouTube.